So quiz next Tuesday. All right. So there will be like 16, 17 questions on the quiz. I will go through everything that will be on the quiz with you right now. And then you will have to do the sample quiz. So you are prepared for the quiz. Last semester, I had people do sample quizzes like 7 and 8 times to make sure they were ready for the quizzes. Okay? You might want to do that because you need to know what's on the quiz and be able to get them right. So, here we go. Coterminal angles are how far apart from each other? 360. They are 360 apart from each other. What's 133 plus 360? 493. What's 133 minus 360? Negative 227? I'll go with that. So, are these two angles, 315.6 and negative 764.4, coterminal? Well, let's take negative 764.4 and add 360 to it. You get negative 400.4 or negative 404.4, right? And add 360 to that. What do you get? Negative 44.4. And add 360 to that. What do you get? Are they coterminal? Yes. Because they're a multiple of 360 apart. Okay? So you just keep adding 360 to this one. Or I suppose you could subtract 360 from this one and just keep going until they meet. If they don't meet, then they're not coterminal. If they meet, they're coterminal. Understand? Okay. 248 degrees. Where on the coordinate system is 248 degrees? Quadrant 3. Because this is 180, this is 270. 248 is somewhere in between 180 and 270. How do we convert from decimal, or how do we convert from degrees, minutes, seconds into decimals? Do you multiply by 60 or divide by 60? Divide by 60. Divide by 60. So this is 41.54 over 60 is 9, right? 41.9 degrees. So if you're converting 2 degrees, minutes, seconds, we take the decimal part and multiply by 60. What's 0.94 times 60? 0.94 times 60. 56.4. And then you take the 0.4 part times 60. And what do you get? 24. So this is negative 21 degrees, 56 minutes, and 24 seconds. Degrees, minutes, seconds. So you just cut off the decimal part, multiply by 60. Cut off the decimal part, multiply by 60. Okay? And the whole number part is what is there. Converting from degrees to radians, we multiply by 2 pi over what? No. 2 pi is how far around the circle? 360. So instead of multiplying by 2 pi over 360, why don't we multiply by 1 pi over 180? Would that work? On your calculator, put 225 over 180. What do you get? What? 1 1/4. Okay. So 1 1/4 pi, which is 5 pi over 4. Properly done. 5 pi over 4. Okay. Because 225 over 180, if you do the second AB over C button, if you have one of those little Texas Instruments calculators, they'll give you that. Graphing calculator should probably give you 5 over 4. It won't put it in a mixed number form. 225 over 180 hit equals. All right. Since they gave us the same problem twice in a row, let's change the number. Let's say this is 120 degrees. Okay? Convert that to radian measure. Well, if you multiply by pi over 180, what do you get? 0.3 repeating, but what as a fraction? Yeah, it's not 0.3 repeating, it's 0.6 repeating, man. Well, 2 pi over 3. Okay? How do you convert from radians to degrees? From radians to degrees. Okay? Instead of, somebody said divide by pi over 180. Well, yes, in fact, dividing by pi over 180 works, but when you divide by a fraction, you multiply by its reciprocal. So multiply by pi over 180, or 180 over pi. The pi's cancel. 180 over 20 is 9. 9 times 9 is 81 degrees. Convert from degrees to radians. Now, this one an integer or a decimal. This one wants an integer or decimal, but round to the nearest thousandth place. So if we multiply by 180 and divide by pi, there's no pi's to cancel, so you're going to get a decimal that'll never end because it's going to be an irrational number. So you're going to round to the nearest thousandth place. If you don't learn how to read, I'll take points off because, some of you were pre-calc. It was like, Mr. Bierschbach, I didn't round right. Can you give me some points back, please? And I, was nice sometimes and did that. But, please try to read the directions. All right, 67.8 times 180 divided by pi, what do we get? What? 388.4 what? Oh, 3,884 point. What did it say? Round where? What am I having a tirade over? Thousandths. So 3 decimal points. So make sure you round to the right place. Because that is upsetting to me if you can't read the directions to round to the proper place. All right. Coterminal angles. Coterminal angles are how far apart? 360 degrees, which is the same as how many pi's? 2 pi. So you're going to take whatever they give you, in this case it's pi over 6, and add 2 pi onto that. Well, what's the problem with that? They don't have a common denominator. So this is equal to pi over 6 plus how many pi over 6? 2 pi is the same as 12 pi over 6, which gives us 13 pi over 6. So we look, whoa, there it is. There's a 13 pi over 6 right here, okay? If we add another 12 pi over 6, we get 25 pi over 6. If we subtract 12 pi over 6 from pi over 6, we get negative 11 pi over 6, and so on. So we know that's the answer. Okay, let's do another one of those. Let's say you were given 4 pi over 3. What are two coterminal angles that are coterminal with 4 pi over 3? One bigger, one smaller. So we're going to add 2 pi onto this, which is how many pi over 3? 6 pi over 3, which gives you 10 pi over 3. What's 4 pi over 3 minus 6 pi over 3? Negative 2 pi over 3. Can you do that? Get a common denominator, turn 2 pi into whatever the common denominator is. Okay? What quadrant is 8 pi over 5 in? Ooh, I wouldn't know right off the top of my head. I know it's past 180 degrees, but I don't know if it's in quadrant 3 or 4 for sure. So what I would do is change this into degrees. How do we change this into degrees? 180 over pi. Very good. Pi's cancel. 5 goes into 180 36 times. 8 times 36 is 288 degrees, right? What quadrant am I in? 4. Quadrant 4. Find the length of the intercepted arc followed by the following central angle of the circle with a given radius. Okay. Now, our angle is 5.1. Is that in degrees? No, that's radians. So if they give it to us in radians, we have to use the trig formula for arc length. What is the trig formula for arc length? Arc length equals that times that. The angle times the radius. So take 5.1 times 102. Rounded to the nearest tenth, 520.2. Actually, there's no rounding on that one because it worked out to be exactly that. Okay? Now, we're looking for arc length. Ooh, we're looking for radius given the arc length. And since this is in degrees, what formula do you use? Trig or geometry? Geometry. So, arc length 69 equals 36 over 360 times 2 pi r. What are we solving for? R. So, I know that 36 over 360 is 1 over 10. So how do I get rid of my fraction? Multiply by 10. 10 cancels. So 690 equals 2 pi r. Divide by 2. 345 equals pi r. Divide by pi. And I can't do that in my head. 345 divided by 3.14159265. 109.816917. Okay, what does it say in the directions? Nearest hundredth. So 109 point what? 109.82. Okay, we good there? Sector area. Is this geometry formula or trig formula? Trig formula, because we're given the arc or the angle in radians. So the trig formula for sector area is the angle times r squared divided by 2. So our angle is pi over 5 times the radius is 20, square it, and then divide it by 2. So it's pi over 5 times 400 divided by 2. Well, 400 goes into 5 80 times. 80 divided by 2 is 40. So you get 40 pi. And they want an exact answer, so that's how you type it in. If you hit 40 times pi in your calculator and give me 12 or 122.6, I'll count it wrong. Okay? Because it's 40 pi, because it says type an exact answer using pi. How do we simplify this? We cancel what units? We cancel radians and radians, minutes and minutes, so we're going to end up with revolutions per hour. 10 times 60 is 600, so it's 600 divided by 2 pi, which is 300 divided by pi, which is what? Rounded to the nearest tenth. 95.5 revolutions per hour. A windmill for generating electricity has a blade 30 feet long. Depending on the wind, it rotates at various velocities. Find the angular velocity in radians per second for the tip of the blade if the windmill is rotating at 85 revolutions per second. So where do we start? With the 30 or the 85? 85. What's your next step into finding angular velocity? Do we multiply by 30? Multiply by 2 pi, because there's 2 pi radians in 1 revolution. Revolutions cancel. We're at radians per second. So what do we have this 30 there for? Just to confuse you. So don't get confused if they put in extra information. Okay? 2 pi times 85, it says round to the nearest tenth. So take 170 times pi. That's a pretty big number. What? 534 point. Okay. So a typical saw blade rotates at 3,200 revolutions per minute. What's the linear velocity of the blade for a 9-inch blade? So basically, if we're flipping it over and having it go down the road, how fast is that saw going down the road? So where do we start? 3,200 revolutions per minute. Once we have revolutions per minute written down, where do we go? Multiply by 2 pi radians per 1 revolution. Revolutions cancel. Now I have radians per minute. I need to get it to miles per hour. How do I get rid of my radians? Multiply by the radius. So the radius is what? 4.5, because if it's a 9-inch diameter blade, the radius is 4.5 inches per 1 radius. The radians cancel. Okay? So now I have inches per minute. I need miles per hour. How do I change inches into miles? There's 12 inches in 1 foot. And there's 5,280 feet in 1 mile. So feet and feet cancel, inches and inches cancel. And now we have miles per minute. We need miles per hour, so we multiply by 60 minutes per 1 hour. Minutes and minutes cancel. So then we get miles per hour. So you take 3,200 times 2 times pi times 4.5 times 60 divided by 12 divided by 5280. $85.7 miles per hour. Okay, last one. Pretty impressed. Has a roller that's 16 inches in diameter. The speed of the plane roller moves at 76 feet per second. What is the angular speed? So here we have to work backwards. We start out with 76 feet per second, and we want to get radians per second. So how, if we know the roller is 16 inches in diameter, what do we do? First step. Well, I got feet involved and I got inches involved. What do you do if you have feet and inches involved? Okay, so how do I multiply? What do I multiply by? 12. There's 12 inches in a foot, right? So is 12 on top, 12 on bottom? 12 inches per 1 foot. So I got inches per second. I want radians per second. How do I change inches into radians? The radius. What is my radius? 8 inches per radius, right? So I got inches squared over second radiuses. Flip it. Come on, Mr. Bierschbach. Flip it. So in my 1 radius, I have 8. Wow. 8 inches. So inches and inches cancel. So you take 76 times 12 divided by 8. That should come out to be a nice number. What? 114 radians per second. Okay, basics. That's the basics of what will be on your quiz. So, I will put a sample quiz out there you can do today. Oh, I guess we can spend this afternoon working on the sample quiz. If you get it wrong the first time, you can work on it again or whatever. But yeah, I suppose because I'm being super nice to you, that's all we'll do today. We will take the quiz next time. Yep.